Just about 30 years ago, we didn't have any scientific proof of a planet outside our solar system. Today, thanks to advances in technology and scientific research, we've discovered over 5,300 exoplanets, alien worlds that are out there waiting to be explored. At first, these discoveries mostly involved large gas giants, but as our capabilities have expanded, we've started to uncover smaller, Earth-like exoplanets. Scientists have already found more than 50 exoplanets with masses similar to Earth, and over 800 worlds with radii less than 1.5 times that of Earth. We don't know of many such planets orbiting within the habitable zone of their parent stars, where the conditions are just right to support life. But that's already starting to change. As our search for habitable planets continues, we're beginning to discover entire planetary systems with more than one potentially habitable world. And we already know about at least one such system in our cosmic neighborhood. Our Milky Way galaxy contains numerous compact planetary systems centered around stars similar to our Sun. However, planets orbiting closely around these stars are usually too hot and therefore unsuitable for supporting life. But when it comes to colder, fainter stars, the habitable zone lies much closer to the star. This is Gliese 667, also known as GJ 667, a triple star system located in the constellation Scorpius, about 23 light-years from Earth. It contains the first known example of a system where a low-mass star has multiple potentially habitable rocky planets orbiting within its Goldilocks zone. Similar to Alpha Centauri, the system contains 3 stars. GJ 667a is a K-type main sequence star and the largest member of the system. This orange-red dwarf has a mass equal to 73% of the Sun, a radius equal to 76% of the Sun, and a visual luminosity of only about 12% that of the Sun. At an average distance of 12.5 astronomical units lies its companion, GJ 667b. It is also a K-type orange-red dwarf, with about 69% of the Sun's mass, and radiates only about 5% of the Sun's visual luminosity. And just like with Alpha Centauri, the most interesting member of the system is the third star. Gliese 667c is an M-type red dwarf, with a mass and radius only about 1/3 that of the Sun. It is also incredibly faint, with a luminosity of just 1.4% of the Sun's, and has a comparatively cool surface temperature of 3,775 Kelvin, compared with the Sun's 5,772 Kelvin. Yet despite its small size, GJ 667c hosts a surprisingly rich planetary system. Initially, scientists believed there were only 3 exoplanets orbiting Gliese 667c, but after reanalyzing existing data and making additional observations, they discovered there may actually be 6 planets in the system, with 3, or possibly even 4, potentially habitable super-Earths. So what exactly is a super-Earth? The term is used to describe a planet that's larger than Earth, but not quite as large as the gas giants like Jupiter and Saturn. These planets can be made of rock, or a mixture of rock and ice, and they may have atmospheres capable of supporting different forms of life. The closest planet to the star, Gliese 667cb, is a scorching hot world with a surface temperature of around 200 degrees Celsius, 392 degrees Fahrenheit. Being the most massive planet in the system, about 5.5 times the mass of Earth, this exoplanet probably has a very thick atmosphere and completes one orbit around its host star in just 7 days. The 3 potentially habitable planets in the Gliese 667 system are all located farther away from their host star. They each have masses between 1 and 5 times that of Earth, making them excellent candidates for habitability. Gliese 667cc, the next closest planet, orbits near the inner edge of the star's habitable zone. It has a mass about 3.8 times that of Earth, a radius about 1.8 times Earth's, and completes one orbit every 28 Earth days. With an Earth Similarity Index, ESI, of 0.85, It has been described as the holy grail of extrasolar planets. Because of the red dwarf's low energy output, the habitable zone around GJ667c lies very close to the star, extending from approximately 0.11 astronomical units to 0.23 astronomical units, entirely within the orbit of Mercury in our solar system. For comparison, Earth orbits the Sun at approximately 1 astronomical unit. If our planet orbited GJ667c at that same distance, it would become a frozen ice world. GJ667cc orbits its parent star roughly 8 times closer than Earth orbits the Sun, at a distance of approximately 0.12 astronomical units, completing one orbit every 28 days. Because of this close proximity, the planet is likely tidally locked, with one hemisphere experiencing permanent daylight while the other remains in eternal darkness. The drastic temperature differences between these two hemispheres probably have a major influence on the planet's global climate. Gliese 667cc receives about 10% less visible light than Earth receives from the Sun. However, because most of the radiation emitted by its red dwarf star is infrared, the planet receives nearly the same total amount of energy as Earth does. This could help liquid water remain stable on its surface and potentially produce a climate somewhat similar to Earth's. Because scientists don't yet know whether the planet has an atmosphere or how thick that atmosphere might be, it's impossible to predict the exact surface temperature of Gliese 667cc. If the planet does possess an Earth-like atmosphere, it could redistribute heat around the globe, producing temperatures as pleasant as 30 degrees Celsius, 86 degrees Fahrenheit, even on the permanent night side. Living on such a planet would be a very different experience. GJ667cc would be illuminated by the faint reddish glow of its parent star. The other two stars, Gliese 667a and Gliese 667b, lie approximately 230 astronomical units away, much farther than the distance between Pluto and the Sun, and are well outside the planetary system. Even so, those two distant suns would still appear in the sky as a pair of brilliant stars during the day. At night, together they would shine with a brightness comparable to that of Earth's full moon. And our own Sun would appear as nothing more than a distant star. Unfortunately, the nearby red dwarf is known to produce powerful stellar flares, intense bursts of radiation and energetic particles that can be up to 1,000 times stronger than flares from our own Sun. This could pose a serious challenge for any potential life on the surface of Gliese 667cc, since the planet orbits very close to its active host star. The strong magnetic activity of the red dwarf may also produce large star spots, which can reduce the star's energy output by as much as 40% for months at a time. Combined with the relatively low levels of ultraviolet radiation, this could present yet another obstacle for the development of life as we know it. Living on Gliese 667cc would also be very different because of its greater mass. The higher mass of the planet means stronger gravitational acceleration at its surface. Since this world is believed to be rocky, its surface gravity could be up to 60% stronger than Earth's. A person weighing 75 kilograms, 165 pounds, on Earth would effectively weigh around 120 kilograms, 265 pounds, on Gliese 667cc. In addition, a more massive planet can retain a much denser atmosphere, resulting in higher atmospheric pressure at the surface. If the planet has an atmosphere similar to Earth's, the Surther pressure might only be a few times greater. However, if Gliese 667cc has a Venus-like atmosphere, the pressure could be hundreds of times higher, comparable to the pressure found several kilometers beneath Earth's oceans. Despite being located within the habitable zone, Gliese 667cc may not experience Earth-like conditions. Any life that evolved there would likely need to adapt to fluctuating dim light, potentially high atmospheric pressure, and frequent stellar flares. But that doesn't mean life couldn't exist on such a world. After all, we've already seen remarkable examples of life's adaptability here on Earth. The other two potentially habitable planets are almost identical. Gliese 667ce mass 2.7 Earth masses, radius 1.45 Earth radii, and Gliese 667cf, mass 2.7 Earth masses, radius 1.45 Earth radii. Both orbit farther away from their parent star, meaning they receive less energy. This could make them too cold to support life as we know it. However, unlike GJ667cc, a thick atmosphere would actually be beneficial on these worlds because it could trap heat and maintain temperatures suitable for liquid water. Finding 3 potentially habitable planets within the same planetary system is already extraordinarily rare. Finding 4 would be almost unimaginable. According to one study, 5 planets in the Gliese 667c system are estimated to receive between 20% and 200% of the solar energy that Earth receives from the Sun, making all of them potential candidates for habitability. But there are many other factors involved. Scientists have determined that, for a planet with Earth's mass, the habitable zone around Gliese 667c has 2 boundaries. The inner boundary lies between 0.095 and 0.126 astronomical units, while the outer boundary extends from 0.241 to 0.251 astronomical units. Any planet orbiting within this region around Gliese 667c may be capable of sustaining liquid water on its surface, giving it the potential to support life. If a planet is too close to its star, the intense heat will cause water to evaporate into vapor and eventually escape into space, making the planet uninhabitable. This happens because water vapor is itself a greenhouse gas, capable of trapping heat and driving temperatures to intolerable levels through a runaway greenhouse effect. Only the more massive planets located near the inner edge of the habitable zone are believed to be more resistant to this moist greenhouse process. On the other hand, if a planet is too far from its star, such as the proposed outermost planet, Gliese 667cg, it risks becoming completely frozen. While gases such as carbon dioxide, CO2, can help warm a planet through the greenhouse effect, too much CO2 can actually cool the planet by reflecting incoming starlight back into space. So there is a limit to how much carbon dioxide can contribute to warming a planet. In 2013, astronomers announced that Gliese 667c has a minimum of 6 confirmed planets, with the possibility of a 7th planet, designated GJ667ch. Although its existence remains highly controversial, this proposed exoplanet could be the smallest world discovered around Gliese 667c, with a minimum mass of about 1.1 Earth masses. Orbiting at approximately 0.0893 astronomical units from its parent star, Planet H would likely be far too hot for life as we know it. However, Gliese 667cf and Gliese 667ce are confirmed to orbit within the habitable zone, and although the estimated orbit of Gliese 667cd lies just beyond the outer edge of the habitable zone, its orbit remains uncertain. This means that Gliese 667cd, cf, ce, and possibly even CD are all potential candidates for habitability. The discovery of densely packed planetary systems around M-dwarf stars, such as Gliese 667c, points to the existence of countless planetary systems throughout the galaxy, each potentially containing several habitable worlds. Since M-dwarfs make up more than 70% of all stars in our cosmic neighborhood, the number of promising planetary systems in the Milky Way is likely far greater than previously imagined. Instead of searching across 10 different stars for a single potentially habitable planet, scientists can now focus on one star that may host multiple Earth 2.0 candidates. As new and working advanced telescopes continue to be developed, our ability to uncover the mysteries of the universe is growing at an exponential rate. What star system would you like to hear about next? Sound off in the comments. Stay tuned to be among the first to hear about the next big discovery in the cosmos. And if you enjoyed the video, make sure you click the super thanks button. Thanks for watching.